So, scientific notation. You might have heard of this in your science class already. If you haven't, well, okay, we're going to learn it now. So, scientific notation, this is used for numbers that are either really, really, really big or numbers that are really, really, really small. Because it can be sometimes hard to know exactly what a really, really big number is just by glancing at it, or a really, really small number is, and sometimes don't want to write out the whole number over and over and over again, especially if it's going to be a lot of zeros in there. Especially if it's going to be a lot of zeros in there, like 1 million. You might not want to write 1 million over and over and over again. Scientific notation is here to help us with that. So in scientific notation, numbers are always written in the form of a times 10 to the b. That's any number times 10, this 10 stays the same, to a different power. Where b is an integer, that's between, where b is an integer, and a is between 1 and 10, the numbers 1 and 10. So it has to have exactly one non-zero digit before a decimal. It has to have exactly one non-zero digit before a decimal. So like I said earlier, this notation is especially useful for numbers that are either very small, or very small, or very, very large. That's when this notation is really, really helpful, is when numbers are just super small or they're super big. This notation is going to be very helpful for us. So make sure you fill this in. Okay, we have these blanks that we're already filling in. Make sure you're doing that. So here we have some examples. So if we have the number 1.07, 1.07 is between 1 and 10, times 10 to the 4th. That's going to be like 1, but then you move the decimal places 4 times. It's going to be 10,700. 1.07 times 10 to the 3rd. Same thing, except for the exponent is one smaller, right? 1.07 is the same, right? Times 10 is the same. The only difference is that this is the power of 4, this is the power of 3, right? But what do we notice about this number versus this number? This one has one more 0, right? Okay. How many numbers follow this 1? Follow the 1. Okay, let's try that again. How many numbers, in this first example here, wherever my pen's at, how many numbers follow this 1? 4. And what's the exponent? 4. And this one down here, how many numbers follow the 1? 3. What's the exponent?
3.
How many numbers follow the 1?
2.
What's the exponent?
2.
How many numbers follow the 1 before the decimal? Just 1. And what's the exponent? 1. How many numbers follow the 1 before the decimal? 0. And what's the exponent? 0. Okay? So, that's how this is basically going to work, is we're just essentially going to think of this as moving our decimal. We're going to just think of it as moving our decimal. So, what would be 10 to the 4th? Well, we talked about before, that's like if you have 10, 10 to the 4th would be the same thing as 10 with how many zeros? Or 1 with how many zeros? 1 with 4 zeros. It would look like that. And if you multiply these with each other, if you guys are familiar with the metric system at all, for every 0, you basically just move over the decimal 1 more. So if we have 1.07, we're going to move the decimal over 4 times. 1, 2. Can I move it over any more?
Yes.
Yeah, but what do I have to do?
Add a 0.
Add a 0. Can I move it another time?
Yes.
Add a 0. Have I moved the decimal 1, 2, 3, 4 times? Yeah, and that's how we get the answer 10,700, like we got here. Whereas here, it'd be the same thing, but it'd be 1.07 times 1 with 3 zeros behind it, 1,000. And so you move this decimal over, 1.07 3 times. 1, 2, make a placeholder 0, and 3. So you have 1,070. What do we notice about these negative exponents, though? What's happening with the numbers? They go backwards, right? So as the numbers get bigger, as the exponents get bigger, the number gets bigger. As the exponents get smaller, the number gets smaller. Because 10 to the negative 1 is like you're multiplying by 1 over 10, right? What's 10 to the negative 1? It's 1 over 10. So that'd be like you're dividing by 10. And if you divide this by 10, that'd be like moving the decimal one place this way. So it would be like 0.107. With the power of negative 2, you move it over 2 to the left. Power of negative 3, you move it over 3 to the left. 1, 2, 3 to the left. Power of negative 4, you move it over 4 to the left. And just like, let's see, let's write on that, let's forget. Just like up here, where we had to add zeros in for placeholders when we ran out of actual digits, we can do the same thing. So if it's 1.07 times 10 to the negative third, we're going to move the decimal how many places? We're going to move the decimal how many places?
3 times.
3 times. That's the exponent. Which direction we're going to move it, left or right? Left. Think about it this way. On the number line, which way is negative, left or right? Left. The exponent's negative, we're going to move it to the left. So, move it once. Move it again. What do I have to add to move it again?
0.
What do I have to add to move it the third time?
0.
And the decimal's now over here. So it's 0.00107. And is that what we had up here?
Yes.
Yes. One note I want to state is that, once again, notice here is that the positive exponent, go and write this in, positive exponent makes the number bigger. So the positive exponent on 10 makes the number bigger. What do you think I'm going to say about the negative exponents? Yeah, the negative exponents, so go and write that in. Negative exponents makes the number smaller. Get better. Fill out crossbook. What is 10 to the power of 0?
Nothing. It is the same number.
It's not nothing. Anything to the power of 0 is what, Krista? 1. Anything to the power of 0 is 1. So on this one, where's the power of 0? On this, where's the power of 0? That means you're taking like 1.07. You're taking 1.07 times what number? 1. And then you'll just get itself, right? When it's to the power of 0, it stays the same. When 10 to the power of 0, it stays the same. Questions on this before we go on and start using it a little bit? It's all about moving the decimal. It's all about moving the decimal. Alright. So if we're going to put numbers in scientific notation now, we're going to work on putting them into scientific notation. Yes.
Could I teach these?
I'll have you go up and do the first one if you want.
Okay.
Okay, so you're going to explain it?
Okay, so since basically what I did is you need to have it below 10. So I moved the decimal point from here to here, which means I moved it once, so it's 5.2 times 10 to the first.
The decimal's on the other side of the 2.
Yeah, it's decimal point here, moved to here.
Alright, so originally, can I see this, Lisa? Thank you. So originally when we look at this, it's like a 52.0, right? If we don't see anything there, it's like there's a decimal at the end of it. If you don't see anything there, it's like a decimal's after it. Just like if you don't see anything there, it's over the number of 1. If you don't see anything there, the decimal's after it. So like on this one, the decimal would be after it because you don't see it there. And so Justin said, I need to move this decimal one place. One place. And so I get moved between the 5 and the 2 because we want this number to be between 1 and 10. And is 5 between 1 and 10?
Yeah.
Yes. We only want one number in front of the decimal. And now we have the other numbers behind it. And we moved it over 1. Now how can we remember this has to be a positive 1 instead of a negative 1? Anna? What was that? Okay. I didn't move it backwards. I didn't make the number bigger, okay? So if this is 5.2 times 10 to the first, this is a positive exponent, right? So that means this number is actually going to be bigger or smaller than it looks like right now? It's going to be bigger. And is the number actually bigger than it looks like right now?
Yeah.
Yes, so that's how we can remember it's correct, okay? That's how we can remember it's correct. Think about, okay, if I were to put it back, like normal, I would need to go positive, which is which direction on the number line? Right, positive is right. So if I were to put it back into normal, I'd have to go to the right, which is positive. That's correct. Let's look at the second one. 8,452. We have our decimal here at the end. If we don't see it, we just put one there. Where are we going to want to put this decimal at? Between what two numbers? Between what two numbers are we going to want to put the decimal at, Graydon? The 8 and the 4. So how many spots do we have to move it to get to the 8, between the 8 and the 4? Kale showing me 3. 1, 2, and 3. I think Kale's right. So what am I going to write now? Sam, what would I write? Alright, so Sam said 8.452 times 10 to the negative 3. Do we agree?
I disagree.
Okay, you have a confused look on your face. What are you saying? What are you thinking? You know, what do you think, buddy? I'm not sure. Anna, what are you thinking? Why are you thinking the exponent should be positive? Okay, we didn't move it to make the number bigger, we didn't move it to make the number smaller, okay? Think about it, if we're making this number smaller, we made this number smaller, so we have to make our exponent bigger. It's like a balance, it's like a scale. Okay, if you move one smaller, it has to go somewhere, it doesn't just disappear, so the exponent has to get bigger. If you're making it this smaller, you have to make the exponent bigger. Does that make sense? Okay. Why couldn't we just write 8.4? Why did we have to have the 5.2 on there as well?
Because it was part of the original problem.
It's part of the original question. I want you guys to do the third one. Go ahead and do the third one, please.
Can I help check?
This one? Sure, why don't you go ahead and do it. And I might need to get a step stool for you.
Yeah. Because we're working right now, though. We're good. Wait, I don't want you.
Tap away from it. And let it leave there. There you go.
I got it.
Explain.
Okay. So your decimal's here. So then I usually just count from because I know it has to be smaller than 10. So then you have your 2. So then I count how many numbers are after
So why do we have to have that 0 at the end? I see a 0 at the end in the original, but I don't see one in your writing.
Because it's a 0, and why not?
It's a 0, okay? So if you know you're going to have to move it 8 places, then we know we can add on that 0 afterwards. We know we can add on that 0 afterwards. It's not going to be a concern to us. Actually, in scientific notation, you wouldn't. To be technical, you actually would not put the 0. You only put zeros if they're between two other numbers. In scientific notation, you only put zeros if they're between two other numbers. Alright, yep, stop them back. Okay, questions on that one? Alright, I want you guys to go ahead and do 4 through 6 if you haven't already. I know quite a bit of you have. If you haven't already, go ahead and do 4 through 6, please.
Oh wait, can I go on really quick?
Did I see it?
Yeah. You already checked my report.
Oh, no, no, sorry.
Yeah, I know. I've done this like.
Okay.
It was such a read. It was such a read because at the school that I moved to, they would just say they go.
That is not a
Well, no, no,
two.
finish the next
That's
page.
a one. Is that a negative sign or a positive sign? Wait, no, that is. Wait, I didn't check your last one. Where's the two?
I don't know.
You have this thing all backwards.
I don't know.
It should be two, and we should end in 8, not start with 8 and end in 2. Redo it.
Well, we go.
And
Oh yeah, well, you're not right there.
it's not supposed to be dead center. No.
Okay.
-4. You don't know how to count. You count right.
It ain't much,
Hey,
but it's
Devin,
fun.
what'd you get for number 4? Guys, what's off?
4 times 10 to the negative second.
Awesome. 4 times 10 to the negative second, right? We have to move this decimal how many places to the right? 2, to make sure the 4 is in front of it. And if we make, just like we have a number line right now, we have a number line. Where are the smaller numbers at on this ruler? The left. Where are the bigger numbers at?
Right.
The right, okay? So this number, did we make this number bigger or smaller? 0.04, did we make that bigger or smaller? We made that bigger, okay? So if I have my hand here, and I move it this way to make it bigger, that means we still have the rest of the ruler though, right? We still have the rest of the ruler, so even if I slide this to make it look bigger, that means we have more on this end. So we have to add more to the exponent. We have to add more to the exponent. This exponent has to have a bigger number going to, or the exponent has to go to a smaller number, excuse me. So I made the number, that explanation was incorrect. When we made this number bigger, we had to make the exponent smaller. So when we make the exponent bigger, we took away from the other side to make it bigger. When we made the exponent bigger, we took away from the other side to make it smaller. Alright, Cam, what do you have for this 5th example?
I had 8.8
2, 3, 4, 5, 6, 7. I agree. So did we make 8? We made 8.8. We made this into a bigger number, right? So if this got bigger, the exponent has to get smaller. Whenever one gets bigger, the other gets smaller. Or if one gets smaller, the other gets bigger. Okay, and Jacob, what'd you get on your the sixth one?
2.0008 times 10 negative 4.
Very good. We have to move this exponent over 1, 2, 3, 4 times and put it right there. Make the number bigger, we have to make the exponent smaller, going negative 4. And we still have to include these 3 zeros and the 8. We can't lose those zeros because they're between two numbers. If they were at the end like it was here, we could. Or if they're at the beginning like it was here, we cut them off. But we cannot lose these since they're between two numbers. Questions on these? Okay, do you guys think we could go the other way?
Yeah.
From having numbers in scientific notation and writing them like normal. Okay? I want you guys to actually go ahead and work on these 6. I want you guys to go ahead and work on these 6.
Not quite. We'll talk about that one. We'll talk about that. I'll have you go around and I'll check with these for 6. You want me to go around and check this? I appreciate it. So here, you made this number smaller. You made this one smaller. And you made this number bigger. There you go. Correct. There you go. And then guys, negative. Yes. We're gonna go around and check those 6. Okay.
Mr. Cost,
Yeah.
why is number 5 not in science?
So.
No, it's not.
Yeah. Just make your test with it.
Okay, good.
Oh, she,
Dude, you just.
you were counting.
Okay.
Yeah, you just glance at it and say yes.
Yeah, I'm smart.
I had to do this.
I had to do this within like 3 different schools because I kept moving schools, and so it was like every time I moved, it was the same exact thing. Yeah, basically. They just had different things. This is a decimal, right? So I did it like I learned like twice in elementary, twice in middle school. No, because I didn't go to the elementary.
Well, I did it in my own.
Yeah,
That
we
was,
both
that
go
was
to
the first to see. You know how Miss?
I literally went to elementary school training. I went to 2 different elementary schools. And the reason why it was like different is because I was in an advanced school. Because apparently I was. Yeah, I used to be smart.
Oh, I tried. To erase your campus. I tried to erase it, but you see those little things? Oh, that would be that.
Oh yeah, I did.
That was beautiful. Yeah.
Yeah, I can see that. Like alien things, food.
Yeah, we're both gonna be up. Let's
I
What?
That's what I do for my walking years. I just go to
Jacob, I trashed.
bird walk off.
Did you see my
And
little?
I just reach out and drop them.
Fire car on the.
Dad has
I like it too. But I wish it was white instead of beige. Oh, I got that. I want.
Hey, let's go back to our seats, please. Let's go back to our seats, and please don't sit on my desk. It just it's not good for the desk long term. But hey, so this first one, how many decimal places do we move? Or how many places do we move the decimal? 4. Now we're gonna make this number bigger or smaller? Bigger. We can think, what do we have to do to our exponent to get it back down to having no exponent here? We can make this smaller. We're gonna have to make this number bigger. And if it's positive exponent, we're gonna go positive on a number line, which is to the right. So we're gonna move over 1, 2, 3. What do we have to do to move to our fourth? Add a 0. So we end up writing 42030, which is 42,030. Sam, how many decimal places do we move on the second one? 5. So you have 3, 2, 1, 2, 3, 4, 5. 320,000. Questions on that? Blake, what'd you get on 3? You don't even know? So here we moved this 5, right? We moved this 4 places. How many times are we going to move this decimal? 0. So if you move the 0, is it going to move it all? No, that's just 3.14. And Blake, if we think about this, what is anything to the power of 0? I heard it? 1. So this is like 3.14 times 1. And what's anything times 1? Itself. So it's just 3.14. Okay? So we move the decimal how many times this exponent here? Betsy, what direction do we move the decimal on number 4 though? Move to the left. It's a negative number on a number line. Left is negative, so we will move it left when the exponent is negative. We can also think we're making this number bigger to go to 0. To make this number smaller. One gets bigger, one gets smaller. So move the decimal left. 1, 2. What number do we have to add right to the decimal? 0. William, what'd you get for 5? Yes. So you can have a 0 here before the decimal. You don't have to have it. If you do, that's okay. 0.0005. 4 zeros there. 5. Move the decimal over 4 times, creating 4 zeros. Grace, what do you have on 6? 7 zeros. So 1, 2, 3, 4, 5, 6, 7. Followed by 5, 5, 5. Move it over once, then you have 7 more to move it. So we're going to create 7 zeros to move it. And if you want, you can track through 1, 2, 3, 4, 5, 6, 7, and our 8th one there to get through all of them. Questions on these? Okay, so let's work on multiplying and dividing these. So we're going to multiply and divide these. What we're first going to do is we're going to group different numbers around. We're going to group different numbers together. We're going to group our regular numbers together, and then we're going to group the powers of 10 together. So we're going to group our regular numbers together, like what would be multiplied by 10. And then we're going to group our powers of 10 together, so like our 10 to the 5th and 10 to the 4th. And we're going to rewrite our answer in scientific notation as well. So if we look at number 1 here, 2.0 times 10 to the 5th, is this scientific notation right here in the parentheses? Okay, times 4.0 times 10 to the 4th. Is this scientific notation here? Yes, and they're all being multiplied together. Okay, so what numbers do we have that are the normal numbers? Not the exponents, the normal numbers. 2 and 4. So we're going to put those together and put 2 times 4 in one parenthesis. We're going to regroup that. We're going to put 2 times 4 in one parenthesis. We're going to have these multiplying together in this other one. This sign here in the middle is what we're going to put in here. And they're being multiplied together, and we're going to put the powers of 10 together. So we have 10 to the 5th and 10 to the 4th. And now we're going to do these problems. So we're going to regroup it. We regroup it into our normal numbers and our powers of 10 in the other parenthesis. Our normal numbers in one parenthesis, and our powers of 10 in the other parenthesis. What is 2 times 4? 10 to the 5th and 10 to the 4th. What do we do if we have the same base for multiplying? Add the exponent. So it's 10 to the 9th. So what do we have here? 8 times 10 to the 9th. How can we write that in scientific notation? Just write 8 times 10 to the 9th. Does that look more like scientific notation now? Yeah. Now, what we could do, we don't want to do this, so I'm gonna write this out the long way, so don't write this part, don't write this part. Once again, don't write this part. We could do 2, 3, 4, 5, write this whole thing out. 2.0 times 10 to the 5th, and write out 4 times 10 to the 4th, and actually multiply those, and then put it back in scientific notation. But is that more work? I think so. We could do that. We could do that, say 4 times 2 is 8, and then tack on all of these zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then move the decimal back over every time, and get 8 times 10 to the 9th. But I think this way is a little bit easier for us. We're going to try the same thing with the second one now. 3.0 times 10 to the second, is that scientific notation? 5.0 times 10 to the 6th, is this scientific notation? And what operation are these two different parentheses doing with each other? Multiplying. So what are we going to group together in the first parentheses? The normal numbers, which are 3 and 5. Very good. 3 times 5 in one parenthesis. What's going to go in the other parenthesis here? 10 to the second times 10 to the 6th. Our scientific notation numbers are exponents, our powers of 10. So now we say, Betsy, what is 3 times 5? 15. Jacob, what is 10 to the second times 10 to the 6th?
10 to the
10
8.
to the 8th. Very good. We add the exponents. Is it 15 times 10 to the 8th? Is that quite scientific notation yet? No. What do we have to do? We have to make it in between 1 and 10. So what do we have to do from 15 times 10 to the 8th to get this into scientific notation? What do we have to do with this decimal? Move to the left one. And what do we do with this exponent? Make it bigger. We made this number smaller. We have to make this number bigger. So it would be 1.5 times 10 to the 9th. So we group and multiply and divide, and then we have to rewrite our answer. So sometimes we have to check to write our answer. Because after we got 3 times 5, it became too big, so we had to move it again. Does that make sense? Make sure if you have a question, we're asking them, okay? I want you guys to do the third one. I want you guys to do the third one. Are you ready for that scientific notation now? Rewrite that in scientific notation now. You can't have a number 10. It's smaller than 10. Right, so in between 0 and 10.
Zero, okay. Well done.
You want to go right now, Jeff? Sure. You want to go right now, Jeff?
Yes.
Great. You want to go right now, Jeff? Don't talk too excited, okay? So we have to make it smaller, right? So we got one number plus rubber decimal. Yep.
Yes.
There you go. Okay, good.
Let's go. Oh, where's your next? Yeah, right there. Just save that.
Okay, yeah, yeah, but then you do it over again.
Right. I don't
You have to make it from your 10 because
Oh,
it
you
has to
think
be
of that.
green on the nine.
If you have four, let's not get rid of the you get many for advantage.
higher than the decimal of 1. So, or if you have 4,
They
you're
did
getting
somewhere to
$13
keep my
per
house.
cent.
Oh, wait, no.
It'll be 10. That kind of helps us think about it. Think about money. I always like thinking of things as money.
Oh.
I don't know how you got 10 to the negative.
Because I
Because I got
multiplied
this.
4 with
Still.
Okay, so here, what numbers are we going to group together? What numbers are we going to group together? Derek, help me out.
I mean,
Because I called your name.
2.5 and 4.0.
Okay, 2.5 and 4.0 are regular numbers. And what are the other numbers we're going to group together, Christian? Okay, so the powers of 10. So group our normal numbers together and a powers of 10. 2.5 times 4. If we don't know that right away, we can think of 2.5 as $2.50. 2.5, $2.50, $2.50. What would you have if it took 4 times $2.50? $10. So it's 10. That can help us out. 10 to the negative third and 10 to the fourth. What do we do with those exponents here, Jacob?
Sorry.
10 to the negative third and 10 to the fourth. What do we do with those exponents?
Oh, well, you put them together.
Okay, and we get 10 to the
First.
first. 10 to the power of 1.
Yeah.
So negative 3 plus 4 is 1. And so now, is this number only one number in front of the decimal? No, we need to move it, right? So how many times do we need to move this decimal? So it becomes 1 times 10 to the power of 2. We move this decimal, make this number smaller, we have to make the exponent bigger. So we get 1 times 10 to the second. 1 times 10 to the power of 2, or the second. Questions on that one? Okay, on 4 through 6, what's changing? We're doing division instead of multiplication, okay? We're doing division instead of multiplication on 4 through 6. So what I want us to think of here is we're still going to group those same numbers together. So what numbers are going to group in the first parentheses here? 8 and 4. But this time, we're not doing multiplication. What operation are we doing between these? Division. So we put that division sign in the middle. So we take this division sign and we put it in between those. And what number is going to go in the second set of parentheses? 10 to the 7th divided by the same sign times 10 to the 3rd. But these parentheses are still going to multiply with each other. And we'll see why in a second. These parentheses are still going to multiply with each other, and we'll see why in a second. But we put this division sign in the ones inside the parentheses. Just like this multiplication here was what went in the parentheses. Now the division sign goes in between the parentheses. What's 8 divided by 4? 2. What do we do when we have 10 to the 7th divided by 10 to the 3rd? Subtract them. So we have 10 to the 4th, because 7 minus 3 is 4. Now, for this to be scientific notation, do we need this to be 2 times 10 to the 4th or 2 divided by 10 to the 4th?
2 times 10.
Times. So that's a helpful way we can remember that these parentheses are still being multiplied with each other. Still multiplication going on with each other. So it's still 2 times 10 to the 4th. And do we need to change this at all to make this scientific notation? No, it already is. Questions on that fourth one? So what was the only difference here between these first 3? You put division between these. You put division between these, right?
Yeah.
Okay. I want you guys to do 5 and 6. 5 and 6. I want you to do 5 and 6 here.
Oh, yeah. I didn't know which. Ah. Yeah. Just are. I wanna be a parent. What? Got something to say to my face.
Yeah, you're right.
Seven. Why is negative? Turns out you get on the wrong.
I was done before you.
Are we doing both albums right
Yep.
now?
Yep.
Oh.
5 answers, please.
Tell him no because
I still play with my game.
You're right, Mario Bros. Using your resources.
I have an idea.
I have Super Mario Bros. 1. I know
Super Mario Bros.
I have Yoshi Island.
I have Super Mario Bros.
there's no say.
It does. You can show it's not Chinese, it's Japanese. It's uncultured. Yeah.
There we are. Not that bad. Oh, hey, if we can make our way back to our seats, please. Make our way back to our seats, please. Thank you. Make our way back to our seats, please. Thank you.
You have to give it.
I do.
This is Oh, it's easy.
Okay. So on the second one, Benjamin, wait, please. On the fifth one, what two numbers are we going to group together first? On the fifth one on the board on our notes, what two numbers do we group together first?
Oh, 4.5 and 1.5.
4.5 and 1.5, and we're dividing, right? In the second parenthesis, what do we put? 10 to the 7. Guys, focus up. We only got a couple minutes. Let's keep going. Divided by 10 to the negative second. 4.5 divided by 1.5. How many times does $1.50 go into $4.50? 3. Here, when we divide, we subtract. Write it out if you need, okay? Don't do mental math and make a mistake. 7 minus negative 2 means you add. So it's times 10 to the 9th. And we're done. On the sixth one, we group together 7 divided by 3.5 and put this division here. We're going to have 10 to the negative 6 divided by 10 to the negative 4. Go back up yet, guys. I'll get you out on time. Go back up. Thank you. 7 divided by 3.5. 2. 350 goes into 7 twice. Take a bit of money. 10 to the negative 6 divided by 10 to the negative 4. Negative 6 minus the negative 4. 10 to the negative second. So it ends up being 2 times 10 to the negative second in scientific notation. Any questions on those? On your homework, look at numbers 19, 20, 21, and 22. Look at numbers 19, 20, 21, and 22, the last 4. What operation do you see between that 10 to between the two parts? You see a dot there, right?
Yeah.
Whereas on the others, you see just 2 parentheses next to each other. What do 2 parentheses mean next to each other? Those dots there on 19 through 22, those dots there, those are supposed to be division. That's supposed to be division and misprinted. So on 19 through 22, here, make sure we're doing division. Make sure we're doing division on 19 through 22 there. Questions on that? On 19 through 22, make sure we do division. When is this going to be due? Next class, which is Friday. Now you may pack up. Yeah. Yeah, I'll put you on there.
Oh, wow.
You can take me off that much cost, but you know that I'm done. So,
You haven't retaken it yet, though.
what?
You haven't retaken it yet, though.
I just
Mr.
did
Costa,
corrections.
will you put me on
Yeah,
the list?
you have to retake. Corrections don't raise your grade in here.
What?
I'm a main teacher.
I thought you said you could just do corrections and get half credit.
You can do corrections on the ones you missed and then just retake the parts you missed for half credit. You still have to retake the parts you missed.